Hello viewers, welcome back to another section of my tutorial. In this video we're going to solve applied electricity trial question. Okay, so it says calculate the total resistance between the terminals A and B of the circuit shown in the figure below. So this is the figure here, and it says all resistances are in kilo ohm. So you can see this resistor, and we have a delta connection of resistors here, and also this forms another delta connection of resistors. So we are to find the effective resistance, that the total resistance. So follow the video to the end so that you get a full understanding of this concept. Let me divide my working space since we're going to be redrawing severally. So at this point I'm going to redraw. So what I'm going to do is I'm going to convert this delta connection here into a star form so that simplification will be easy. So let's see, I have this terminal A here as well as I have my terminal B. So A move to the 12, moves down here to this one, and this one also comes down, it also comes down to form this, then finally this go here, this also comes here, this comes to join. So take care when you are redrawing so that I draw the right diagram. So I'm finally done with my redrawing now. So I'm going to introduce my star connection. So you let me write the values here. I have 12, I have 18, I have 12 here, I also have 6, 5 and 6. So when I'm introducing the star, each terminal of the star is supposed to be in between two of the resistors in a delta connection. So I'll introduce one here, one here. It will come to this point and I'll make a node here, and let me add one here in between the 5 and the 6. Then finally let me bring it down. So any way you draw it, it's correct, but make sure that each terminal is found in between two of the resistors. Now let me label my star resistors as A, B and C. So let's find the value for A, B and C. So A is equal to, you multiply the two resistors in which the terminal is in between, and after you divide it by the sum of all the three resistors. So adding all the three resistors, I'm going to have 6 plus 6, 12 plus 5 making 17. Then I'll multiply these two, 36, so I'll have 36 on 17. Then B will be equal to 5 times 6, 30 all over 17. Then finally my C will be equal to this 5 times this 6, 30 also over 17. The next step is to redraw. Then after, I'm going to substitute the values here. So redrawing back again. So I'm going to have, now when you are redrawing with the star connection, you have to take care so that you make sure that your drawing is accurate, otherwise you get it wrong. So observe it carefully as I redraw. So at this point I'm going to move straight to the star part. So moving straight to the star part, then I'll come down, then here I'll use this to join to this part, this one here, I'll join that one here like this. I complete my star here, and the star will come down here, then finally it will go here like this. So labeling, this is my 12 here, this is another 12 up here, this is my 18. Now this is my A, so the A was 36 on 17. Then also I have my B here, sorry I left the C, so the C is somewhere here, the C is somewhere here. So the B is also 30 on 17, then my C 30 on 17. So at this point you can see that some of the resistors are now in series, that is the 12 and the 36 on 17 are in series. So let me combine them and see what you are going to get. So 12 and the 36 on 17 being in series, you add them. 12 plus 36 on 17. And what am I getting for that? 240 over 17. So this place will give me 240 over 17. Then, so let's make it 12 plus 36 on 17, 240 over 17. Then as well as 18 and 30 over 17 are also in series because there is no node in between them. So 18 plus 30 on 17, and that is giving me 336 on 17. So 18 plus 30 on 17 is giving me 336 on 17. So 336 on 17. So let me redraw and also put in my values here. So I'm going to have my 12 back again. Then the 12 will go here. Then let me give the effective values here. Finally, then this will move to this side like this. Then to the C. Then also back to my B terminal, where here is the A terminal. So I can see that this is the sum of the 30, this and the 12. That will give me this part. So 240 on 17 will be this. Then this place will be the other part, which is 336 on 17, where I have here to be 30 on 17. Then here is 12. So I move further to my simplification, and I can see that these two are now in parallel. So in parallel connection, I'm going to multiply the two of them. That is 240 on 17 multiplying 336 on 17. Then you add the two resistors. So 240 on 17 plus 336 on 17, and that is giving me 140 on 17. So I'm going to get this A here, I have my 12 here, then this coming down to this, then finally to my B. So 12, then I have 140 on 17, then here is also 30 on 17. At this point, you can see that all the resistors are now in series in between the terminals A and B. So I just move forward adding them. I'm going to have 12 plus 140 over 17, then plus 30 on 17. So I can add this since they have the same denominator. So this is going to give me 170 over 17 plus 12. Let me add this on my calculator. 12 plus 170 over 17. So I can see that 170 over 17, 17 go here 10. So I'm going to be left with 12 plus 10. And that will give me 22. And they said all resistances are in kilo ohm. So 22 kilo ohm is going to be the total resistance in between the terminals A and B. Thanks for watching. Kindly subscribe and also don't forget to like.